Hi everyone, welcome to goclasses. So in this session, we will solve SQL questions. Uh, so we will see some gate questions and we will see some practice questions. Okay. So some easy questions. First, we will see some easy questions. Okay. Straightforward questions. And then we will see some good quality questions. And then we will see some gate questions. Okay. So take your copy pen and let's do it together. Okay. Let's solve all the questions together. So this is our module 2 queries. Okay. We have already seen relation algebra. We have already seen TRC, tuple relation calculus, and SQL. Almost everything in SQL we have seen. One topic is remaining, that is nested queries. That nested query we will see in the next lecture. But let's solve some questions of SQL and some gate questions. Let's solve. Okay. So let's start now. So let's see some practice questions of SQL. This is our question number 1. This is an easy question. So tell me what is the answer quickly. This is a very easy question. So basically, you have a table from scores. This is your table. The name of this table is score. Okay, consider the given table is scores. Select score 1, score 2. Okay, so if you select score 1, score 2, then you can notice duplicates will not be eliminated. Yes or no? The select clause will not remove the duplicates. So what your output will be, tell me. If you do this, then this will be your output, right? Okay. So if you notice this is going to be your output as it is. Okay. This is going to be your output as it is. Yes or no? Because you are selecting, select in the SQL, that is projection, right? Yes or no? So in the SQL, this select is basically the projection. Okay. So you are projecting the attributes. So these two attributes, score 1, score 2, these two attributes you are projecting. Okay. So finally your output will be this as it is. Okay. So in the output total, there will be 6 tuples. And you can notice which of the following rows is in the answer. So you can notice that 1, 2 is not in the answer. 5, 3 is in the answer, right? Okay, so your answer will be option B. So this is a very easy question. If they ask you number of tuples, then number of tuples will be in the output. What will be number of tuples in the output? In the output, what will be number of tuples? That will be 6. Okay, number of tuples in the output is 6. Now let's move on. This was an easy question. This is another easy question. So tell me what is the answer. The question is saying that consider this relation. Okay, 4 attributes and query. This query is given to you. Which tuple is in the result? So what we are doing, we are select star, means all the attributes we are selecting from scores where run 4 is equal to 5. So your output will be what? If you notice, your output will be from this table. You are selecting those tuples where runs 4 this is greater than 5. Okay, so you can notice this tuple will be gone. Okay, this tuple will be gone, this tuple will be gone, this tuple will be gone. Okay, and you can notice this tuple will be gone, this tuple will be gone, this tuple will be gone, this so you can notice. Okay, now I can say that this tuple will be gone, this tuple will be gone. So these tuples are gone. Okay, these tuples are gone. And finally the remaining tuples. So total how many tuples are remaining? You can notice, okay, this tuple remaining, this tuple remaining, this tuple remaining, and this tuple remaining. Total 4 tuples are remaining. Okay, total 4 tuples will be remaining. So number of tuples in the output, that will be 4. Number of tuples in output. Okay, number of tuples in output, that will be 4. So total 4 tuples will be in the output. You are selecting all the attributes. Okay, every attribute you are selecting. Select star means every attribute you are projecting. So, okay, so your answer will be what? You just tell me. Your answer will be uh, okay, so this option A will be the answer, right? Okay, so your answer will be option A. So option A is going to be the answer because you are selecting all the attributes. Okay, so that is the reason option B is not the answer. Why? Option B is not the answer because you are selecting all the attributes. Okay, all the attributes we are selecting. So the answer will be option A. Now let's see this question. Another very easy question. Tell me the answer. Another very easy question. So what the question is saying that from RST. Okay, so from RST means basically conceptually you will do the cross product, right? Okay, so from RST, that simply means that conceptually you will do the cross product. After that, what you will do, you will apply this condition. This condition you will apply that RB is equal to SA. Okay, so you will do the cross product, and in the cross product you will do r dot b equal to s dot a, and s dot b is not equal to t dot b. Okay, so tell me which of the following is true. 0 1 1 0 appears twice. Okay, let's see this option. 0 1 1 0. What about this option? Will it appear twice? 0 1 1 0. Remember, you're projecting what you are projecting. Remember, this is what you are projecting. You are projecting r a r b. Okay, so this is what you are projecting. Remember, this is what you are projecting. You are projecting this also, you are projecting this also. Now the question is saying 0 1 1 0 means, so what it means, it means 0 1 will come from here. Agree or not? 0 1 will come from here. 0 1. Okay, so because we are projecting ra rb sb tb, so this 0 1, this 0 1 can only come from here. This is the only possibility that 0 1 comes from here. And then this tuple will match with the what, which tuple? Tell me. Remember, this tuple will match with which tuple? So rb should be equal to sa. rb should be equal to sa. So this tuple will match with these two tuples. Next, and this condition must be there. sb should not be equal to tb. sb should not be equal to tb. So this will match with these. Okay, sb should not be equal to tb, and this will match with these. Correct? Okay, so finally what I am saying, that these tuples will satisfy. So this 0 1. Okay, so these tuples, all these tuples are going to satisfy, right? Yes or no? So rb must be equal to this. So for this tuple, if you take this tuple, then with this tuple you can notice this will match with this, because you can notice rb and sa both are same, and sb should not be equal to ta. Sorry, tb. Oh, okay. sb should not be equal to tb. sb should not be equal to tb. So this will match with this and this. sb should not be equal to tb. This will match with this and this. sb should not match with tb. So, and this will match with this and this. sb should not match with tb. Okay, this will match with this and this. Yeah. Okay, so finally what you will get, then in this situation I can say that you will get these rows. This 0 1 you will get, this 0 1 1 0. So how are you getting? Remember, this 0 1 1 0. Okay, this 0 1 1 0 you will get this 0 1, and then you can notice 1, and then you can notice 0. That's correct, right? So you will get it 2 times. So this is correct. This option is correct. So option A is correct, right? Yes or no? This is true. Okay, this is a true, because you are getting this. Okay, you will basically you will get this 0 1. Remember, you are projecting this you are projecting, this you are projecting, this you are projecting. So remember, you will get 0 1 from here, and you can notice you will get one, ultimately you will get this 0 from here, and you will get this 1 from here, this 0 1 0 1 from here. Also what you will get, you will get 0 1. Okay, so you can notice you will get 0 1, and this 1 you will get from here. So this 1 you are getting from here, this 0 you are getting from here, this 1 you are getting from here, and this 0 you are getting from here. So you can notice you will get 1 0 0 1 1 0. So 4 tuples you will get here. Yes or no? 4 tuples you will get. So you can notice this tuple you are getting 2 times. 0 1 1 0. This tuple you are getting 2 times, and 0 1 0 1. This also you are getting 2 times. So 2 times this you are getting, 2 times this you are getting. What else? What about this 1 1 0 1? So for that, what you need? Okay, let's check. So basically you are checking this. In this, let's checking option A. In this you are checking option A, right? In this you are checking option A. So if you check option A, this is what you are going to get. Now let's check option B. Tell me. Checking option B. So checking option B. So if you check option B, then what will happen? 1 1 0 1. So this is your 1 1. Okay, this is your 1 1. Now after this, so this will match with what? This will match with RB equal to SA. So this will match with these two. This will match with these two. And again, the same thing will happen, that RB should not be equal to TB. So this 0, it will match with this and this. And you can notice this 1, it will match with this and this. Okay. So here again, the same thing will happen. Again, the same thing will happen, that this 1, 1, this 1, 1 you will get from here. This 0 you will get from here. So 0, 1, 0, 1. Okay. So this 0 you will get from here, this, and this 1 you will get from here. So like this it will happen. Also what will happen? It will happen that 1, 1, this 1 you will get from here, then 1. Okay, so you will get 1, 1, 1, 1, 1, 1, 1, 1. So 2 times you will get this, 2 times you will get this. So this option is wrong. What about the option C? What about the option C? 1, 1, 1, 1, 1, 0. 1, 1, 1, 0. This appears once. Okay, this does not appear anytime. So this is also wrong. Okay, this does not appear. This, okay, 0. Yes or no? It does not appear. It does not appear. So answer will be option A. Is this clear to everyone? Please tell me. So here you can notice that these rows will be in the output. So you can very easily see. Okay, what will be the number of tuples in the output? If the question asks you number of tuples in the output, what will be number of tuples in the output? Let's check it out. One thing you can clearly see that RB should be equal to SA, right? Okay, so RB should be equal to SA. So this will match, for example, this will match with these two, right? Yes or no? And you can notice that this 0, it will match with these two, because RB should not be equal to TB. So this 0 will match with these two. And you can notice this 1 will match with these. This 1 will match with these, right? Correct. So for everything it will happen. For every tuple it is happening. So you can notice every tuple is giving you 4 tuples. Agree or not? Yes or no? Every tuple is giving you 4 tuples, like 0, 0, 0, 0. Then you can notice 0 here, and this 0, 1, 0, 0, 0, 1. What else you are getting? You are getting 0, 0. And you can notice you will take 1 from here, and you can notice 0. So you will get 1, 0, 0, 0, 1, 0. So you can notice every tuple of A is giving you 4 tuples in the output. So finally your answer will be what? That will be 4 multiplied by 4. So that will be 16. Is this clear to everyone? Tell me. So total 16 tuples you will get in the output. Every tuple 2 times. Every tuple 2 times. Yes or no? Every tuple twice. Every tuple basically is repeating 2 times. So, okay. Appears once. This will not appear. How it will appear? See, this is never going to appear. Wait. With 1, 1, you will match with these two. Okay. So this will come with this. So 1, 1, 0, 1, 1, 1, 0, 1. Okay. Next 1, 1. 1, 0. Yeah, this is 1, 0, right? That's correct, right? Yes or no? This will be correct. Yes. Okay. This will be correct. So again, you can notice. So this answer is correct. This answer is still wrong. Okay. This answer is still wrong. This answer will still be wrong. Okay. Is this clear? So this is, yeah, this is correct. Okay. This is correct. So actually there will be total 16 tuples in the output. Okay. And these 16 tuples are like this. In all these 16 tuples, what will happen? The last two will be different. See, in all these 16 tuples, what will happen? The last two will be different. Yes or no? In all the 16 tuples, last two will be different. Last two will be different in all the 16 tuples. In all the 16 tuples, last two will be different. Like for example, okay, this will be last two column, and before that, what you can do? Before that, you can put any of these, yes or no? Before that, you can put any of these. For example, you can put 0, 0, 0, 0, 0, 0, 0, 0. Yes or no? Okay. Or you can put, or the same thing will happen. These last, they will 0, 1, 0, 1, 1, 0, 1, 0. And then what you can put? You can put anything you want. Okay. For example, you can put 1, 0, 1, 0, 1, 0, 1, 0. Right? Yes or no? So like this total 16 tuples you will get. This type of 16 tuples you will get. So you can definitely see this tuple will repeat 2 times. That is correct. This tuple does not appear. This will appear. Yes or no? This will appear 2 times. Okay. This will appear 2 times. It will appear 2 times. So I can say, for example, I can say it will appear. Okay. This appear 2 times, twice. This is also correct. And you can notice this appear twice. This will also appear twice. This will also appear twice. Okay. This is also correct. For example, this will never appear. Yes or no? Like 1, 1, 1, 1 never appears. Okay. Never appears. This 1, 1, 1, 1. Is this clear to everyone? So you can notice a simple thing. You can notice that in the previous question, what is happening? You are projecting RA, RB, SB, TB. And the condition was this. The condition was already this, that this should not be equal to TB. This was already the condition. Okay. And yeah, RB, yeah. Okay. So this was the condition, right? That SB should not be equal to TB. Okay. And there was one condition, that is RB should not be equal to SA, but here you don't have SA. So this is what you are projecting. So these two will always be different. Okay. So whatever you do, these two always will be different. Like if these two always will be different. Okay. Now you can put, like, okay, basically now you can put whatever you want to. Is this clear? So the last two will always be different. The last two will always be different. And now here you can put whatever you want to put. Okay. Is this clear? Here you can put 0, 0, or here you can put 0, 1, or here you can put 1, 0, or here you can put 1, 1. So like this it will happen. Okay. So this is a like good question. In this question, many things can be asked. Yes or no? In this question, many things can be asked. Like they can ask you many questions, like, okay, who will appear, what will appear, okay, something like this. Like regular expression they can ask. Yes or no? Like regular expression, what is appearing? What is the regular expression of what is appearing? Regular expression of output tuples. What is that? Regular expression of output tuples. So at the end, either 1, 0 should be there, or 0, 1 should be there. At the end, either this should be there or this should be there, right? Okay. At the end, either this should be there or this should be there. In the beginning, you can take this also. Okay. You can take this also. You can take this also. You can take this also. Isn't it? Okay. Right. So you can notice. But this will happen 2 times. Okay. But everything will repeat 2 times. So I can say regular expression of distinct output tuples. Yes or no? Distinct output tuples is this. And in the actual output, what will happen? In the actual output, every tuple will repeat 2 times. Every tuple appear 2 times. So like this is your answer. Okay. So like this, you can basically write. Now let's move on. Let's see this question. Tell me the answer. Let's see this question. Tell me the answer. Very simple question again. From scores, select distinct team, runs for. team comma runs for. Okay, so your answer will be team comma runs for. So you are selecting this attribute and you are selecting this attribute. So this attribute gone, this attribute gone, right? Okay, so these two attributes are gone and you are selecting distinct and you are selecting distinct. If you are selecting distinct, then what will happen? Duplicates will be gone. Okay, duplicates will be gone. So you can notice one appears how many times? One will appear how many times? One will appear 2 times, right? Okay, one will appear 2 times. You can notice this attribute is gone. This attribute is gone. Okay, so this is gone. This is gone. So finally, you can see definitely what is E option? That is none of these. A option is none of these. So you can clearly see here one will, so this option is wrong. 5 appears twice. Okay, this is 5, this is 5. So will 5 appear twice? Yeah, that's correct. 5 will appear twice, right? Okay, next 6 appear 4 times. 6 even we don't have even 4 times. We don't even have 4 times. So the answer will be only option B. Yes or no? The answer will be only option B. Next, let's see this question. Tell me quickly the answer. Let's see this. This is a question on order by, like select ABC. You are selecting ABC from R and you are ordering by C descending, B ascending. Okay. So C descending, B ascending. This is what you are doing. So tell me the answer. And the question is saying, what condition must a tuple satisfy so that T necessarily precedes? T necessarily precedes. Is it talking about immediately preceding? Is it talking about immediately preceding? Is it talking about immediately preceding? So this is a mistake. Many people, okay, what they think? They think, okay, immediately precede. No, the question is saying precede. It does not mean that they are saying may not be immediate. Yes or no? May not immediately. May not be immediate. Agree or not? So the question is talking about necessarily precedes. May not be, may or may not be immediate. Okay, it simply means that before this your tuple should come. Your tuple should come before this, before this. So tell me, this is your condition, right? C descending, B ascending. So 5, 5, 5. And remember what you are doing? You are doing A, B, C. And your first priority is C descending. This is your first priority. That C should descend. C should descend. So this value, what this value can be? Tell me what this value can be. This value can be 5 or more than 5. Yes or no? This value can be greater than or equal to 5. Agree or not? This value can be greater than or equal to 5. Okay. Okay. So this value must be greater than or equal to 5. So definitely I can say this option is gone. These two are candidate. These two options are candidate. Okay. Now you can notice. Now this is your second priority, that B should be ascending. B should be ascending. B should be ascending. Okay. So if this is 5, see, notice, A, B, C, 5, 5, 5. If this is a 5, if this is 5, if this is 5, see, read the question carefully. If this is 5, now what this should be? If this is 5, now what this should be? Now this should be greater than or equal to 4. Now this should be less than or equal to 5. Agree? Now this should be less than or equal to 5. Another question, ABC. If this is 4 or maybe 3, if this is 3, sorry, if this is 6, now what this should be? Now what this should be? If this is 6, now what this should be? Now this can be anything. Yes or no? Now this can be anything. Now this can be anything. Agree or not? Okay. If this is 6, then now this can be anything. So tell me the answer here. So the first answer, this is wrong. The second, 155. So if this is a 5, then this should, but we cannot compare them. Agree or not? We cannot compare these two. Agree or not? Can we compare these two? Can we compare these two? We cannot compare. So can I say necessarily this will precede? Can I say option B will precede necessarily? Uncomparable. Yes or no? Uncomparable, not comparable. Not comparable. Not comparable. So option B is also not the answer. Agree or not? Because what I am saying, very simple. Remember, this also can happen 555, 155. This is also correct. This is also correct. And 155, 555. This is also correct. So both are correct. Because they are not comparable, we cannot compare them. 555, 155. This is also correct. 155 and 555. This is also correct. Agree or not? The question is very clearly saying necessarily precede. The question is talking about necessarily precede, necessary. What about this 556? This will necessarily precede. Agree or not? This cannot come after 555. This cannot come after 555. This should necessarily precede. So your answer will be option C. Agree or not? Tell me, did you get it? Tell me, did you get it? Okay, very simple question, but you should take care. Yes or no? This could be MSQ question. This could be MSQ, multiple select question. Then some students will answer option B also. If this is MSQ question, some students will answer option B also. Okay, if this is MSQ question, let's assume in the same question, if this is MSQ, and let's assume I change the options. Okay, let's assume I change the options, like I write something random, maybe 5, 553, 535. What about this? Okay, what about these two? If this question is like this, if this is MSQ question and your options are these, then you can definitely see this will not be correct option, because C should go in the descending order. This will not be correct because not necessary. Yes or no? See, this, for this I can say never. For this I can say not necessary. This is the difference. For the option 1 I can say never. For option B I can say not necessarily. And for these three options I can say yes. So this also will be correct. This also will be correct. They will necessarily precede. They will necessarily precede. Okay. So like this, you can tell me in the order by, will order matters? Like why option E? Because this is 8. So C must be in the descending order. This is enough. Now I don't care about B. Now I don't care about B. If the value of C is more, now I don't care about B. We have already seen this. Now B can be anything. If value of C is more, then B can be anything. Okay. Can you notice in the order by, this order matters? Like, will it be same as this? B ascending, D descending. If I ask you B ascending, D descending, in the same question, what I do? I ask you B ascending, D descending. I just change the order. I am changing the order. Okay, only I am changing the order. B ascending. So this ascending is redundant. Yes or no? This ascending is redundant. So B ascending, C descending. Okay, B ascending, C descending. Let's assume I gave you this, and the options are 535. I also give you 535, 510, 535, 510. These also I give you 535, 510. Now tell me 535, 510. Now What is the answer now? So now you have B. Now this is your first. In this situation, this will be the first. So B is ascending. If B is less, then that is done. So can you notice this is guarantee? This is guarantee. Guarantee I can say. Okay. Okay. Next, remember B must be ascending. So this can never happen. Yes or no? Now this can never happen. Now this can never happen because this is ascending. B by default, that is ascending by default. Okay, so this can never happen. This can never happen. What about this next one? Next one. If they are equal, C is descending, right? So this will definitely come before. So this is also correct. This will definitely come because value of B is same. So C is more. So it will definitely come before 555. Definitely it will come before 555. Okay, and what about this? What about this? This may or may not, right? This may or may not. So this will not be the answer. This will not be the answer. Your answer will be C, comma D. Okay, not necessarily. So did you get it? So this is a nice question on the ascending descending order. Yes or no? A nice question on order by clause. Okay, let's see. See, these are standard questions. All these questions are taken from standard top universities. Okay, and tell me the answer for this question. Another very simple question. And let me tell you one thing. Let me tell you one thing. Did you notice this question has come in the GATE exam? We have already done this question in the relational algebra. Do you remember? In the relational algebra, this question has come in the GATE exam. And this question is from the university, from the standard, from the top university. This question is there. So definitely they are not copying from the GATE exam. Yes or no? Definitely, like this question is not copied from the GATE exam, but GATE exam questions can be based on the standard top university questions. Yes or no? So GATE exam questions, many times the GATE exam questions, they are based on top standard questions. Okay. So if you notice, if you remember, this question we have already done in the relational algebra. This question has come in the GATE exam, but from the relational algebra point of view, if you remember this. Okay. So let's solve this question. Tell me the answer now. Consider the following SQL query. Select a distinct S1 S. Okay. So you have two tables. Student table S1, student table S2. Okay. And where the condition is this, S1 dot age is greater than S2 dot age. So, and you have this S1 name and age you are selecting. You are selecting name and age. Basically, those students you are selecting who are not youngest. Yes or no? Who are older than some student. Agree or not? Who are older than some student. Yes or no? So the answer will be what? The query returns those students who are older than youngest students. So the answer will be option D. Correct or not? The answer will be option D. Is this clear? Yes, everyone is giving correct answer. Okay. So is this clear? Very easy question. Should I explain this? Should I explain this? See what this question is saying. The question is saying like this. You have a student table. You have a student table. In that you have a name, comma age. You have name, comma age. In this student table, you have name, comma age. Let's assume you have, for example, maybe name can be anything like, okay. And let's assume age is also 10. Maybe name is A, maybe age is 12, maybe B, that is 14, maybe C, that is 14, maybe D, maybe another C, that is 15. Okay, so maybe this is the table. Now, what your answer will be? Okay, what your answer will be? So here, basically what is happening here? So you are taking the same table 2 times. Yes or no? The same table you are taking 2 times. So you are taking the same table 2 times. The same table you are taking 2 times, S1, S2. Just give me a second. You try this. Just give me a second. On this data, you try this. Hello. Yes. So on this data, on this same data, you apply this. So what you will get? A10, A12, B14, C14, and C15. So on this data, if you apply this, then what is happening? First, you are taking the cross product. Agree or not? First, you are taking the cross product. Okay. First, you are taking the cross product. Then what you are doing? So first, you are taking the cross product, S1 cross S2, conceptual evaluation, conceptual execution. Okay. This is a conceptual execution, right? Yes or no? This is conceptual execution, that you first take the cross product. That is a conceptual evaluation execution. Now, S1 dot age greater than S2 dot age. So what will match? S1 dot age should be greater than S2 dot age. Can you notice there is no one who will match with this person, because these are the youngest? There is no person who will match with this. For example, maybe you can take another person. You can take, okay, you can take D also, whose age is 10. You can take D also, whose age is 10. Can you notice these are the youngest people? These three are the youngest people. These three are the youngest people. So if you notice, there is no one. And finally, in the output, what you are taking S1. Remember, this is what you are taking. In the output, what you are getting? In the output, you are getting S1 dot. Okay, so these people are coming in the output. Remember, these people are coming in the output. Remember, these people are coming in the output. Okay. So tell me, will these youngest people come in the output? Will these people come in the output? They will not come, because there is no one with whom they can satisfy this. S1 dot age is greater than S2 dot age. Yes or no? Like, there is no one with whom this can match. There is no one with whom this can match. This can match. There is no one with whom this can match. Okay, but you can notice this can match. This can match with this. This can match with this. This can match with this. Correct? Okay, so this 12 can match with these people. This 14 can match with this also. This 14 can match with this also. This 14 can match with this also. This also. Okay, the same thing. The 14. Okay, and this 15 can match with. 15 can match with this also. You can notice the 15 can match with this also, and 15 can match with these. So like this, you can notice. Yes or no? So finally, you are selecting output. So you are getting those people who are not youngest. So you are getting those people who are not youngest. Correct? You are getting those people that are older than the youngest students. That are older than youngest students. So this is what you are getting. Option D. Now the same question will become very interesting if you select as to dot name. In the same question, if I select as to dot as name, if I make it as to, now tell me the answer. In the same question, if I make this variation, in the same question, that as to dot as name, as to dot age. In the same question, I am making this variation as to dot as name, as to dot age. So I am selecting those people who are less than someone. Who are less than someone. So those people who are not oldest, agree or not? Who are not oldest, who are younger than oldest, or I can say who are not oldest. Correct? So I can say answer will be what? So for this query, the answer will be here, none of these. If your query is this, then the answer will be none of these. Because remember, now what you are doing? You are doing the cross product, and now this is in the output. Now this is going to the output. Okay, very simple, very simple. Now this is going to the output. Okay, and the condition is this. This age should be greater than this age. So you can notice now what will happen. This will match with this, right? Agree? This will match with this will match with this will match with this will match with this. So finally I can say this a comma 10 will be in the output. Okay, this 15 will not be in the output. Can you notice this will not match with anyone? This will not match with anyone. So this will not be in the output. So answer will be what? For this query, answer will be what? Not oldest. Not oldest. Yes or no? Students who are not oldest. Students who are not oldest. Those you are getting. And in this query, what you are getting? In this query, you are getting students who are not youngest. Okay. So like this, can you handle the variations? Tell me. Please tell me. Like this, can you handle the variations? Okay. So like this, you can do. Very simple questions. Tell me the answer for this question quickly. Another very simple question. Okay. Okay. So tell me the answer for this question. The question. Okay. Before solving this question, let me solve one. Uh, Before solving this question, let me solve this. Let me solve this. Number of tuples in the output. Forget about everything. Forget about everything. Okay. Before you solve this question, just solve this. Number of tuples in the output. Number of tuples in the output. So to get number of tuples in the output, will you analyze the complete query? Will you analyze the complete query? Will you analyze the complete query to get the, tell me, will you analyze the complete query? Will you understand the meaning of the query? Will you understand the meaning of the query? Will you waste your time to understand the meaning of the query? No, you will not waste the time, because I told you a very simple point. I told you, what was that? A simple point. I told you that when you have group by, when there is group by, when there is a group by and no having clause, yes or no? When there is group by and no having clause, then what happens? Then what happens? Then number of tuples in the output. What is that? For every group you will get one tuple. Agree? For every group you will get one tuple. For every group you will get one tuple. So number of tuples in the output, that will be number of groups. But this will happen when, okay, see, this will happen when number of tuples will be output, that will be number of groups. This will happen when distinct is not asked. Okay, this will happen when distinct is not asked. Select, when select distinct is not there. Only when select is there. Select is there. Select distinct is not there. Yes or no? Select must be there, not select distinct. If select is there, not select distinct. Okay, yes or no? Because maybe because of select distinct, maybe some rows can be gone. Okay, can they be gone? No. They can never be gone. Yes or no? Actually, they can never be gone. No. Okay, so sorry for that. They can never be gone. Yes or no? Rows can never be gone. Why? Tell me. Whether you have select or whether you have select distinct, it does not matter. Tell me why. Whether you have select or you have select distinct, that does not matter. Why? Tell me why. What is the reason? Because if you are creating groups, then they will be different on the group attributes. Yes or no? If you are creating groups, then they will be different on the group attributes. The group attribute value will be different. The group attribute value will be different. Yes or no? It does not matter whether you have select or select distinct. Yes or no? It does not matter whether you have select or select distinct, because the group attribute value, they will be different in the output. Okay. So is this clear to everyone? See, very simple what I am saying. Like you have group by, and let's assume you have A, B, and here you have select. In the select, you must have A, B, agree? You must have A, B. You must have A, B. There can be something else. There can be something else. There can be something else. Okay. So like this is your query. Something. Now in this situation, what you can see? If you can notice that for every group, can you get duplicates here? Can you get duplicates here? So what will happen? For every group, you will get one tuple. For every group, you will get one tuple in output. For every group, you will get one tuple in output. And you can notice, they will be different. Okay. Yes or no? So at least these two values will be different. At least A, B values will be different. This combination, at least this value will be different. In output. So whether you take distinct or not, it does not matter. Whether you take distinct or not, it does not matter, because at least these two values will be different in the output. Is this clear to everyone? They may be same or they may be different. Maybe these also can be different. Yes or no? Maybe these also can be different, but at least these two this pair, this tuple will be different in the output, because they will be different in the groups also. For every group also, what will happen? These two will be different. So for every group also, this A, B, this tuple will be different. Is this clear? See, very simple points. Okay. So finally, you can see that. So when there is group by clause and no having clause, then this will happen. This will happen whether you take select or you take select distinct. Whether you take select or select distinct, this will always happen. It does not matter. Okay. Now you tell me the answer for this question, number of tuples. Tell me. So this same table you are taking two times. You can notice XY. So this same table you are taking two times. Remember? Okay. This same table you are taking two times. You are calling it A1, and you can call the another A2. You are calling it A1. You can call another A2. The same table you are taking two times. Okay. The same table you are taking basically two times XY. Okay. Like this 1, 2, 1, 2, 2, 3, 3, 4, 3, 4, 4, 1, 4, 1, 4, 1, 4, 2. So the same table you are taking two times 4, 1, 4, 1, 4, 1, 4, 2. Okay. So this is what you are doing. So this is your from clause. This is your from clause. That is fine. So this is your from clause, that is A1 cross A2. What is the next? The next is first you remove the tuples. Remember, first you remove the tuples. This is very important. This is very important. First you remove the tuples. So this will happen first. This will happen second. Okay. So this will happen second. So what tuples are gone? A1y should be equal to A2x. This A1y, this should be equal to A2x. Okay. This we will keep in the mind. This we will keep in the mind that they should be same, right? That they should be same. We will keep this in the mind that they should be same. These two should be same. We will keep this in the mind. Okay. So they should be same. After that, so after that you are creating the groups. After that you are creating the groups A1x and A2y. So tell me A1x and A2y. So tell me, will this group be created? 1, 2. Will this group be created? 1, 2. Will this 1, 2 group will be created? So this will be created. First of all, this 1, 2 group. Okay, this will happen only when you have equality here. You must have equality here, right? So you can notice this 1, 2 cannot happen like this. So definitely this 1, 2 cannot happen. And this 1, 2 cannot happen also here also. But this one, yeah. So this 1, 2 cannot happen, right? Agree? So this 1, 2 group cannot be there. I am saying groups. How many groups are there? So this 1, 2 group definitely is not there. And what about next? What about 1, 3? What about 1, 3? Yes, this will be there because 2 and 2 they are same, and you can notice 1, 3 will be there. What about 1, 4? What about 1, 4? What about 1, 4? No, nothing else can be there. Nothing else can be there with 1. With 1, nothing else can be there. Yes or no? With 1 only this will be there. With 1 only this will be there. With 2, what will happen? With 1 only this will be there. With 2, what will happen? With 2. With 2, this will happen. See, this is equal to this. This is equal to this. So with 2, 4 will be there. Okay, with 2, 4 will be there. What about the 3? What about 3? So with 3, you can notice. You can notice 3, 1 also will be there. 3, 2 also will be there. Yes or no? 3, 1 be there. 3, 2 will be there. Okay, with 3. What about with 4? What about with 4? So with 4, you can notice this 1 is matching here. So with 4, 2 will be there. And you can notice 4, 3 will be there because this 2 is matching here. This 2 is matching here. So 4, 3 will be there. So these are the groups. Did you get it? Please tell me, did you get it? See, this is a very simple question. You don't have to analyze anything. So your answer will be number of tuples in the output. That will be 3 and 3, 6. Because there are 6 groups. Because there are 6 groups. So your answer will be 6. Isn't it simple? See, the question is very simple. You don't have to analyze the question. If the question is asking number of tuples in the output, then you don't have to analyze the question. Just find out the groups, nothing else. Okay, but remember this condition must be there. This condition must be satisfied. First you satisfy this condition, then you create the groups. So these groups will be there. Okay, these groups will be there. Now, okay, now let's solve this question. Now let's solve this original question. The original question is asking which of the following is in the result? Which of the following is in the result? This is what the question is asking. So you already know what will be in the result. For the result, what will happen? Again, you can notice XY. If you write, then this and this, they should be same. Correct? 1, 1. Okay, like 1, 2. Next, you can notice 2, 3. Next, you can notice 3, 4, 3, 4, 4, 1, 4, 1, 4, 1, 4, 2. Correct? Okay. So this is what you have. So 2 times you can write it. And you can notice this is your A1. and this is your A2. So first you will take the cross product, that is your A1 cross A2. Okay, this is your first step. The second step is this equality, that they must be same. So this and this, they must be same. Okay, this and this, they must be same. So finally you can notice which tuple will be in the output. So will this 132 will be in the output? This 132. Remember, you are taking this. This is your output. This is your output. Which group is how many times? Which group is how many times? So you are saying 1 3. First of all, how to get this 1 3? This 1 3 will be how many times? A1 dot x, A2 dot y, and this count star. Okay. So here I am saying that 1 3. First of all, how this 1 3 will come? See, the 1 3 will come from 1. This 3 will come. By this also it will come. By this also it will come. Right? By this also it will come. So it will come 2 times. It will come 2 times. Correct? So 1 3 will come 2 times. This is correct. What about 4 2? What about 4 2? How many times because of this 4 you will get? So 4 2. How many times you are going to get? 4 2 I want to get. I want to get 4 2. So remember, you can get 4 2 because of this. See, because of this you can get. You can get 4 2 because of this. A very simple thing. I can say that because of this you can get 4 2. Because of this you can get 4 2. Same. So 2 times because of this. Okay, so 2 times you will get because of this, you will get 4 2. So 2 times because of this, 2 times because of this, 2 times because of this. And what else? That's it. So total 6 times you will get it. So total 6 times you will get it. Okay, so this is a very interesting, nice question. Yes or no? A very nice question. That's okay. Because of this 2 times, because of this 2 times, because of this 2 times. Okay, so you will get 2 times because of these. 2 times, 2 times, 2 times you will get. 2 times, 2 times, 2 times. Correct? Okay, so like that. What about 4 3 1? How many times this 4 3 you will get? So you want to get 4 3. 4 3. If you want to get 4 3, the only way is this. The only way is this, to get 4 3. So that you will get only one time. 4 3 you will get one time. Okay, other groups. What are the other groups? So we have seen 1 3 4 to 4 3. 1 3 4 to 4 3. 1 3 4 to 4 3. So what about 2 4 3 1 3 2? What about 2 4? How many times 2 4? How many times this 2 4 will come? So this is your 2. This is your 4. How many times 2 4 will come? So 2 4 will come 2 times. It will come 2 times. Correct? Okay. And what about 3 1? What about 3 1? How many times 3 1 will come? How many times 3 1 will come? So this is your 3. This is your 3. And this is your 1. How many times 3 1 will come? So it will come 6 times. It will come 6 times. Correct? 3 plus 3. Because of these 2 times, because of these 2 times. And then 3 2. How many times 3 2 will be in the output? How many times 3 2 will be in the output? 3 2. 3 2 will be in the output. This is 3. This is 2. Okay, and this is also 2. So how many times 3 2 will be in the output? That will be only one time. One time this will be in the output. So this is your complete analysis of this question. Yes or no? Did you understand this? This is the complete analysis of this question. Very simple question. Did you get it? 3 2. How many times 3 2 will get? Yeah, 3 2 will get 2 times. Right. So you will get 3 2 2 times. Because of this one time, because of this one time. So 3 2 you will get 2 times. Okay. So this is your question, and quite simple question actually. If you do the analysis, this is a very simple question. Now let me tell you another way to analyze this. Let me tell you just another way to analyze this. This can help you. What is the another way to analyze this? That is, forget about all this. Understand the meaning of the query. Forget about everything. What you do, you understand the meaning of the query. Let's understand the meaning of the query. Just forget about everything. Okay, like forget about all these things. Just understand the meaning of the query. What you do, this is what you do. Understand meaning of the query. If you understand meaning of the query, that also will make the question very easy. What the query is saying, the query is actually very simple. The query is saying they should be same, right? So can you notice this type of thing is transitivity? Transitivity comes to your mind that, okay, one is related to two, this two must be here, then this two is related to something, this two is related to something, then this group is creating, then this group is creating, then this group is creating, and then we see number of tuples. Okay, how many times? Yes or no? So transitivity comes to your mind or not? Transitivity comes to your mind or not? What the happening? What this is happening? See, this is happening. See, this is happening. That a1y should be equal to a2x. Okay, this should be happening. Let's call it intermediate. Let's call it via or mid stop. Okay, let's call it mid stop. Via. Okay, let's call it via. You know, like you are going from Bangalore to Delhi via Mumbai, from Bangalore to Delhi via Mumbai, something like that. Okay, so like that. So, and what you are doing, you are taking the initial and final. Agree or not? You are taking initial and final. You are taking initial and final, and this is your stop. You can think as a flight. You can think of this as a flight. In the flight, this is the stop, and this is initial and final. What is happening here? It is happening that if this is related to this, okay, and the same value again should repeat. Okay, so you can notice this way, the same value should repeat. Then let's assume this is related to this. Then what we are doing? Then we are creating the group of this. Then we are creating the group of this. And then we are finding how many times this is happening. Yes or no? And then we are finding how many times this will happen. So how many times this will happen? Can anyone tell me? The number of times this will happen is depends on number of stop. The number of times this will happen, that will be the number of stops. So number of times this will happen will be equal to number of stops. Agree or not? Number of stops, number of mid stops. So this is the question. Now you can solve this question very easily. Okay, now you can solve the question very easily. So now you can notice 1-2 group will not be created. So group will be created when? So this group created when? If and only if there exists a stop. If and only if there exists a stop between them. Yes or no? There exists a stop between them. So this group will be created if and only if there exists a stop between them. Now you can notice 1-2 stop will not be created. Now can you check that 1-2 stop will not be created? Now you can notice 1-2 stop. This 1-2 group will not be created. Why? Because there is no one. There is no middleman. Agree or not? 1-2 group will not be created. 1-2 group will not be created because there is no middleman, no mid stop. There is a direct flight from 1 to 2. There is direct flight. There is no mid. There is no mid. Yes or no? Tell me, is this clear or not? There is no stop. There is a direct flight from 1 to 2. We don't have this type of flight. What people call it? What people call it? This connected. Yeah. Okay. We don't have connected flight. Yes or no? One stop flight. We don't have one stop flight. We have direct flight. Okay. We now you can notice. Now you can notice this 1-3 will be created. Why? Why this 1-3 will be created? This group will be created. Why? This group will be created because you can go from 1 to 2 and you can go from 2 to 3. You can go from 1 to 2 and you can go from 2 to 3. So this group will be created. How many times this group will be created? From 1 to 3, how many times this group will be created? This group will be created 2 times, because you can take this top 2 times. Okay, 1 2 3, 1 2 3. You can also take like this. So 2 times this will happen. Okay. Okay, like this. So is this question clear? What is happening? Is this question clear? What is happening in this question? So now you can notice 1 3 2. This is correct. What about 4,6? 4,2. Let's focus on 4,2. Let's focus on 4,2. So if you see 4, if you see 2, how many middlemen are possible? How many middlemen are possible? How many middlemen are possible? So you can notice this middleman is possible. 3 times this middleman is possible. Actually 6 times. You can take this middleman, then 2 times this middleman will work here. So this middleman you can take 2 times. This middleman you can take 2 times. Okay, so basically 6 times. 6 times this one will work. So this is also correct. Like this, you can solve the question. I hope this point is clear. Okay. So the answer for this question will be, and the same question they can ask you like this. Original destination. See, the same question they can ask you in terms of flight. Yes or no? The same question they can ask you in terms of flight. What is the origin? What is the destination? The same, exactly same question. This is the exactly same question. You can notice this is the exactly same question. 1 to 1 to, and you can notice this. So this is the exactly same question, but they can ask you like this. So is the analysis clear for the previous question? For the previous question, is the analysis clear? Okay, let's see this question. Which is correct? On your screen, 2 queries are given to you. Which is correct? This question is based on what concept? Anyone want to tell me this question is based on what concept? We have seen this concept in the class. This question is based on what concept? This is based on the most common mistake. Yes or no? This is based on the most common mistake. So tell me the answer. Where versus having. When can you use where? Where in the case of group by? Okay, so tell me which query is correct? In this type of question, what you will think? In this type of question, what you will think? Are forget about query. Yes or no? Forget about query. Just see the remaining people affect or not. Yes, poor people matter or not. So tell me, which of them is correct? So find the department ID and number of faculty members for each department having an ID greater than 20. Can you notice in this question, the remaining departments will not matter? Agree or not? Agree or not? Or forget about the query. Forget about the query. Forget about the query. Just forget about the query. Okay, let's forget about. Let's forget about the query. Just forget about the query. Don't care about the query. Okay, let's remove it. You tell me a simple question. Can department ID less than equal to 20 affect your calculation? Can department ID less than equal to 20, can this department affect your calculation? The answer is no. So what we can do, if this cannot affect your calculation, so can be eliminated. So can be eliminated in where clause. So can be eliminated in where clause. Isn't it clear? Before grouping can be eliminated. Before grouping can be eliminated. That's it. That's it. So you can notice this is also correct query. This is also correct query. Both are correct queries. I told you this question will come in the GATE exam. Definitely one day will be there. There will be one day when this question will come in the GATE exam. They will give you two queries. Okay, they will give you these two queries and they will ask you which is correct, which is not correct. They will definitely ask you. Okay, and some tricky question will come. We have already seen that. We have already seen those questions. Okay, tricky questions. But anyway, you can notice. So you can you can use this also. You can use this also. What you can do? Select a count star department ID from faculty. You can directly where, and now you don't have to use the having here, or you can use the having. So here you can use where clause instead of having. Here you can use having. Okay, so both are correct. Yes or no? Is this clear to everyone? So both are correct. Both of them are correct. Okay, let's move on. So both of them are correct. Let's see this question. Tell me the answer quickly. Now the question is saying, suppose we have a relation R, A, B, C, D, E. If we issue a some query is given to you. Group by B, comma E. Group by B, comma E. Okay, from R. What terms can appear in the having condition? What terms can appear here? So the question is asking what cannot appear. Tell me what cannot appear. What cannot appear? Definitely A cannot appear, right? I told you A cannot appear. B can appear. B can appear. B can appear. B can appear. Next. So B can appear, right? Because B can appear. This B can appear here. Count of B also can appear. Count of B also can appear. Sorry. A cannot appear. So they can appear. They can appear. They can appear. Is this clear? They can appear. Okay, so A cannot appear. So this we have already seen. If you remember what we have seen, this we have seen. I told you what was the rule, that if you have group by, and here you have some set of attribute S, or maybe some set, maybe A, B, C. Let's assume. Then in having, what you can have? In having unaggregated, what you can have unaggregated? What you can have unaggregated? What you can have unaggregated? And what you can have aggregated? See, aggregated you can have anything, any attribute. Aggregated you can have any attribute. Okay, but so aggregated you can have any attribute, but unaggregated, these must be subset of group by attributes. Subset of group by attributes. Subset of group by attributes. Okay, unaggregated, this should be subset of group by attributes. We have seen this. So for example, A comma B, that is fine. Yes or no? That is fine. But you cannot put D. You cannot put D. A is fine. B is fine. D is not fine. If you don't put C, that is also fine. Okay, so like this, you can check. Okay. And this you already know. Can you use having clause without group by clause? Can you use having clause without group by clause? The answer is, according to SQL 92, the answer is no. According to SQL standard 92, that answer is no. Okay. So when you have a having clause without using group by clause in the SQL, so you can notice SQL 92 does not allow that. Let's see this question. In this question, you tell me again the same question. You tell me in this question, can I use where clause to get age greater than 18? This question, is this query correct? One query that you can write that is very simple. Like, okay, what I can do? Tell me one query that I can write that is using having clause. Yes or no? I want age of youngest student. I want age of youngest student. What I want? Select. I want age of youngest student. Minimum of age I want. Okay, for each measure. For each measure. From students table. From students table. What should I do the group by? What should I do the group by? Okay, I should group by. Okay, for each measure. So I should group by measure. For each measure, so I should group by measure. Okay, so for each measure, I want the age of youngest student with age greater than 18. I want. So find the age of youngest student with age greater than 18. Okay. For each measure with at least 2 students. For each measure with at least 2 students. With each measure with at least 2 students. Okay, so now this is the question. So I want find the age of youngest student with age greater than 18. Okay, so once you make the group, once you make a group that, okay, this is the measure. Okay, and there are some students. Once you make a group, so what we should do here? Anyone? Ekta is saying from students group by measure having count star greater than 2. No, but how to say this? See this. Okay. So the question was this. The question was actually, okay, I changed the question. Sorry, I have changed the question. Okay, so wait, I have changed the question. So the question is this. Okay, the original question is this, as it is. The original question is this. Now, now the original question is this. The question is saying that find the age of youngest student with age greater than 18 for each measure with at least 2 students of age greater than 18. Okay, this is the question. So for this question, definitely what you can do? For this question, what you can do definitely? First, now you can use, because ultimately you only want those measure with at least 2 students of age greater than 18. So basically you are only interested in age group greater than 18. So now in this situation, you can select, because your complete focus is on age greater than 18. Yes or no? Your complete focus is on people students whose age is greater than 18. So the remaining students, can they affect the answer? The remaining people, can they affect your calculation? Tell me, can the remaining people affect your calculation? Remaining people, can they affect your calculation? They cannot affect your calculation, right? Because the complete focus is on age greater than 18. The complete focus we have on the students whose age is greater than 18. So the remaining students, they cannot affect your calculation. So what you can do? So you can use where clause. So you can use where clause and you can remove the students who are not greater than 18. Okay. Now this is very simple. Okay. Finally, you can just use the having clause so that at least 2 students of age greater than 18 must be there. So that at least 2 students of age greater than 18 must be there. Tell me, is this clear to everyone? See, in this question, you can notice that the complete focus is on age greater than 18. This is the complete focus. We are only focusing on age greater than 18 and the remaining students. You can clearly see that students with age less than equal to 18 do not affect the calculation. Yes or no? Do not affect the calculation. So because they do not affect the calculation, so what you can do? So can remove them. And here actually it is mandatory that you remove them. Yes or no? In this particular question, it is mandatory that you remove them. In this particular question, it is mandatory that you remove them. It is mandatory that you remove them. In this particular question, it is a mandatory thing that you remove them. Okay, let's see this question. Tell me the answer. Tell me the answer for this question quickly. So what the question actually, in the question, he is talking about a view. See, we did not study view, right? Yes or no? We did not study view. So if this question comes in the GATE exam, if some question comes in the GATE exam which you did not study, can you handle that question? This question you can still handle. It is a very common sense question. Yes, Priya, हमने घबराना नहीं है. Very good. Okay, logic is same. We did not study view, but because that is not in the syllabus, we don't have to study. We don't have to study view. But the point is this, that if some question comes in the GATE exam which you did not see before in your preparation, during your preparation, you did not see some question and that question comes in the GATE exam, then you don't have to like worry about it. Okay, you just have to analyze. Your problem solving skills are very good, so you can analyze the question and you can solve it. Okay, so let's solve this question. So as Priya is saying, हमने घबराना नहीं है. Okay, so tell me, what will be the answer for this question? The answer is very simple. First of all, what you do, the question is this. Here from V, first you will calculate V. Agree or not? Are you agree or not? First you will calculate V. This relation R is given to you. Relation R is given to you. First you will calculate V. So first you calculate this view V. This is the definition of V. So first you calculate V. What is V? Define the view. View definition is given to you. View definition is given to you. Create view V as select A plus B as D, comma C. Okay, so in this V, how many attributes are there? In this V, how many attributes are there? How many columns are there? In this V, how many columns are there? 2 columns. One column is D, which is equal to A plus B, right? And another column is C. One column is D, another column is C from R. So first you calculate this view. So this view you can very easily calculate. That will be 2, 3. That will be 3, 3. That will be 3, 4. That will be 5, 5. That will be 6, 1. That will be 5, 4. and that will be 6,6. Quite simple. Agree or not? Quite simple. So the definition of view is given to you. This is the view. This is the view definition. So we have calculated V. Now it is a very simple question. Now this is a simple question that from V, group by D, group by D. How many groups? Group by D. How many groups? If you do group by D, then how many groups you are getting? 3, 3, 2. So total 4 groups you are getting. And how many groups are qualifying? Qualified group. How many are qualified groups? Number of qualified groups. What is that? Okay. Having count star is not equal to 1. Count star is not equal to 1. So you can notice for this count star is 1, right? For this group count star is 1. For the remaining groups count star is not 1. So the qualified groups are 3. There are 3 qualified groups. And the question is asking select D comma sum C. Select D comma sum of C. So you can notice for 3 what you will get? For 3 you will get 7. So your answer will be what? Final answer will be this. D comma sum C. So if D is 3, then summation of C is 7. If D is 5, summation, if D is 5, then summation is 9. And if D is 6, then summation is 7. So your answer is 5,9 will be there. This is your answer. Isn't it simple? The question was very simple, yes or no? So you can solve the question immediately. Okay. So don't worry about the new questions. Don't hesitate about the new questions. You can see, you can define view like this. You can define view like this. And once you define the view, then everything is simple. Yes or no? Once you define the view, then everything is very simple. Like a normal table, you can treat like a normal table. Okay, so tell me, find all the students whose age is not known. How will you do? Find all the students whose age is not known. Whose age is not known. So age is null. This you can do. Okay, is null, is not null. This is what you can use. Okay, tell me quickly, what is the answer for this question quickly? What will be the answer? The question is asking where team is equal to carp. Okay. Count star count runs. Count star count runs. So where team is equal to carp. So first of all, where team is equal to carp, that you, okay, so the remaining will be gone. The remaining will be gone. The remaining will be gone. Okay. So first of all, the remaining are gone. Okay, where team is equal to carp. Now, what is count star? So this is what you have. This is what you have. What is count star? Count star is 2. So now count star will be 2 and count of runs will be 0. So your answer will be 2, 0. Okay. One more thing, that in SQL you can use all these concepts: outer join, natural join, left outer join. Okay, all these concepts, they are as it is used, just like relational algebra. So all these concepts like natural join, you can, join concepts. All these join concepts in SQL, they are exactly same as join concepts in relational algebra. Possible duplication can be there. Okay, possible duplication can be there, but in SQL what happens? In SQL, possible duplication can be there. Duplication possible, right? Duplication possible. This is the only difference. that duplication is possible. In SQL, duplication is possible. Everything else is same. So join concept. For example, you can notice. So here also, no left or right, inner join right. No. You can use these terms are there. In SQL, we have these keywords. In SQL, these are the keywords. Like there is a natural join keyword. Is this clear? This natural join keyword is there. Outer join keyword is there. Okay. This full outer join keyword is there. Left outer join keyword is there. So all these concepts are there. Is this clear? So the join concepts in SQL, they are exactly same as the join concepts in algebra. No difference. The only difference is duplicates. The only difference is there, duplicates are possible. This is the only difference. No other difference. For example, you can notice here. What will be natural join? 3 tuples. Okay, for these two, A, B, B, C, for these two, in the natural inner join, or this is duplicate, you don't have to write it. So in the natural join, there will be 3 tuples. There will be three tuples. This will match with this. So when you do the natural join, then how many dangling tuples? When you do the natural join, how many dangling tuples? Number of dangling tuples. Total number of dangling tuples is 2. One from R, one from S. Yes or no? One dangling tuple from R. This is dangling tuple of R. This is dangling tuple of S. Okay. Similarly, you have natural left outer join. Okay. In the natural left outer join, the dangling tuple of R will be there. The dangling tuple of R you will put. In the right outer join, the dangling tuple of S you will put. Okay. In the natural outer join, the dangling tuple of both R and S you will put. So these concepts we have already seen. Now tell me the answer for this question. This is a very simple standard question. Which of the following tuples of R or S? Which of the following tuples of R or S is dangling? Is dangling? Which of the following tuples of R or S is dangling? And therefore needs to be padded in the outer join. Because the dangling tuples we paired in the outer join, right? Okay. The dangling tuples that we have. So those dangling tuples we pair in the outer join. First of all, you tell me, is this natural full outer join? Is this natural full outer join? Is this conditional full outer join or natural full outer join? In the relational algebra, we have already seen natural outer join, conditional outer join. There are 2 types of outer join. Okay. So this question is conditional outer join, not natural outer join. Okay. Because the condition is given to you. So this is a conditional outer join. Tell me the answer then. This condition is given to you. On the screen, this condition is given. So this is a natural outer join. Conditional full outer join. So the answer will be what? What are the dangling tuples the question is asking? Okay, so the question is saying R full outer join S on this condition is given. This condition is given. Okay, so you can notice RA must be greater than SB. RA must be greater than SB. So this will be dangling tuple. Agree or not? This will be dangling tuple. Because RA must be greater than SB. So this will be dangling tuple. This will definitely be dangling tuple. And RB must be equal to SC. RB must be equal to SC. Okay, so you can check this is the dangling tuple of R. Okay, so give me a minute. You check it out. How many dangling tuples are there? You check it out. Hello. Yes. So what are the dangling tuples? You can notice this 3, 4 will definitely pair. So RA greater than SB. RA greater than SB. And RB equal to SC. So this will actually pair with this, right? Okay. So this tuple, this second tuple will pair with this tuple. These two tuples are going to pair, correct? Okay. So these two tuples are definitely, they are going to pair. So these two tuples will pair. Oh, what about this one? RA greater than SB. RA must be greater than SB and RB equal to SC. So this will pair with this. This will pair with this. So this is also dangling tuple, right? This is dangling tuple of, you can notice this is a dangling tuple of S. This is a dangling tuple of S, correct? This is the dangling tuple of S. So this is dangling tuple of S. Finally, you have two dangling tuples. 1, 2 of R is dangling tuple and 4, 7, 9. So this is your answer. Okay. So you have two dangling tuples. One is, I can say 1, 2 of R. This is a dangling tuple. And 4, 7, 9 of S. These are dangling tuples. These are dangling tuples. Okay. Is this clear? So very simple, this question. Let's see this question. Tell me the answer for this one. This is GATE 2012 question. GATE 2012 question. So tell me the answer now. Which of the following statements are true about an SQL query? An SQL query can contain a having clause even if it does not have a group by clause. Even if it does not have a group by clause. So this statement P is true for practical DBMS, but it is not true for SQL 92. Yes or no? If you notice this P, this is true for practical DBMSs. Like practical DBMSs that you have. Okay, practical DBMSs, this is true. But it is false for, this statement is actually false. It is actually false for SQL 92 standard. And I told you that for the GATE exam, this SQL 92 standard is important. All the standard books, every standard book, they cover SQL 92 standard. So when we study the concepts, we study the concepts of SQL 92. Okay, SQL 1992. So these concepts we study when we study the concepts of SQL. We don't care about the practical DBMS. Okay, we do not care about the practical DBMS. We only care about SQL 92. This is what we use in all the standard books. This is what you will find. Okay, so here I can say this P is false and this Q is true. Only if you can use having clause, only if group by clause is there. So this Q will be true. Next, all attributes of group by clause must appear in the select clause. This is also correct. Again, the same thing. Again, the same thing that this as is true for most DBMS. This is as is true for practical DBMS. All the practical DBMS software that you have, like Microsoft or like, okay, Oracle or whatever, all the practical DBMS software that you have, this is true. But this statement is false for, again, SQL 92. Again, SQL 92 standard, this statement is false. So you can notice this R and S, Q, R, these are true. So the answer will be option C. Is this clear? From the GATE exam point of view, you should prefer SQL 92 because in all the standard books you will find SQL 92. Whatever standard book you study, okay, you will always find SQL 92 concepts. So this SQL 92 concept is what we study. Okay, for all exams, for whatever exams, this is what we use. In your practical life, if you are doing job, then you can use some other software. But for exams, for competitive exams, whatever exam you take, okay, basically concept wise, I can say concept wise. So concept wise, you should prefer SQL 92. So here the answer will be Here the answer will be q comma r. Okay, this is correct. And these two memes you already know. Okay, we have already seen this. For example, when you put some attribute in group by clause but not in select clause, when you put some attribute in the group by clause, some attribute of group by clause, if you don't put in the select clause, then what will happen? Then this will happen. SQL 92, okay, will create the problem. And this is another, you can notice. Okay, when you put having clause without group by clause, then also SQL 92 problem. Okay, so anyway, for this question, answer will be option C. Next, what about this? Tell me, what about this one? What is the answer for this question? Which two statements are true regarding group by clause? Which so the question is saying two statements are true. Okay, so let's see which two statements are true. First of all, read this question. Before you see this question, tell me, column alias, where we create? Where do we create column alias? There are two type of things, yes or no? There are two type of things. One is table alias, yes or no? One is table alias and another is column alias. Table alias we create in the from clause, like from students as s, and this column alias we create in the select clause. In the select clause, we create the column alias. For example, avg of marks as a. Okay, so like this. So remember, column alias we create in the select clause and table alias we create in the from clause, right? So tell me, can I use this alias in the group by? Can I use this alias in the group by? Instead of using the original table name, using the original table name, sorry, okay, two questions I'm asking. Can I use this in group by? Also, can I use this in group by? Which I can use in group by? Like in the group by, which I can use? In the group by, which I can use? Can I use, for example, as dot? For example, can I use as dot marks? In the group by, can I use as dot marks? Is this correct? Will this be correct if I use this? In the group by, if I use as dot marks, will there be any problem? Will there be any problem? There will be no problem. Why? Tell me why there will be no problem. Because before group by, from is already executed. Array from is already executed, right? So this is correct. Because before group by, from is already executed. From is already executed. Yes or no? So from is already executed before group by. So here you already have s. So here you can use s dot marks, no problem. Agree or not? So because from is already executed, after that this group by happens. But if I use this s dot a, s dot, so maybe, okay, something like this, maybe some other alias, let me use marks as m. Can I use this group by m? Can I use this group by m? What is the problem? There is a problem here. This is invalid. Why? Tell me what is the reason. Tell me what is the reason. The reason is very simple. Because at the time of group by, is select executed. At the time of group by, is select executed. At the time of group by, select is not executed. Select will be executed after some time. So here there is no m available. Here there is no m available. See, this is a simple question. Yes or no? Here m is not available. No, I am available here. So a very simple question. So this is the question you can clearly see a very simple point that tell me now, you can use column alias in group by clause. Can we do that? You can use column alias in the group by clause. We cannot do that. So the question is asking for true statement. This is false statement. What the next? Using the where clause. Using the where clause after group by clause excludes the rows after creating groups. This is nonsense option. This is not making any sense. Yes or no? This is not making any sense, this option. This statement is not making any sense. Correct? Where clause happens before group by clause. This where clause, it happens before group by clause. Before group by, the where will happen. Okay. And before creating group, rows will be eliminated. Yes or no? Before creating group, rows will be eliminated. This is correct. This is correct. Before creating group by, sorry, before creating groups, the rows will be eliminated. Rows will be eliminated before creating the groups. What about this? The group by clause is mandatory if you are using aggregate function. Is it mandatory? Clearly this is not mandatory. Yes or no? This is not mandatory. You can use aggregate function in the select clause without group by clause. Okay. And what about the last option? If the select clause has an aggregate function, then those individual columns without an aggregate function in the select clause should be included in the group by clause. This is correct. So these are some true false questions. Did you get them? Did you understand them? Okay, tell me the answer for this question quickly, very quickly. What is the answer? So some tables are given to you: sailors, boats, reserves. For each age between 18 to 25, for each age between 18 to 25, complete the SQL statement that will list the age and average rating, for all sailors of that age, for all sailors of that age. So between this age, we only care about this age. So can I use the where clause? Can I use the where clause? The remaining people, do they matter to me? The remaining people who are less than 18 or more than 25, do they matter to me? They do not matter. Okay, so we can use the where clause. So you can notice we are using the where clause. So this where clause is done. This is done. We are using the where clause. What else? Okay, so average rating for that age. So you will do group by age, group by rating or group by age, group by rating or group by age. You will do group by rating and you want average rating. Okay, so you want average rating. So this AVG is correct. This is not a keyword, not SQL keyword, right? This is not SQL keyword. Okay, so group by as dot age. Did you notice? Did you notice? Did you notice? This as is used. Table alias is can be used. This is what I told you just now. Table alias can be used in group by. Table alias can be used. This I told you just now. This I told you. Okay. Any doubt? Did I say something wrong? Did I say something wrong? Okay, so this will be group by age. Okay, group by age it will happen. It will happen group by age. And remember, table alias can be used. This I told you just now. That table alias can be used in the group by, because this from will execute before the group by. Okay, this from will execute. You can notice this from will execute before the group by. Before the group by, this from will execute. So this table alias you can use in the group by. Okay, so rating, average of rating you will find, and grouping you will done based on age. So your answer will be option A. This is not a keyword, so this is wrong. Option B is wrong. Okay, let's take this question. What is the answer? Give me a second, you try this. So tell me the answer. In the context of group by clause, what is aggregation in context of group by clause? So very simple, combining data, similar table into one row, into one row. So the answer will be option. Combine data of similar rows into one row, into one row. So summary, group level summary. Okay, we already know this. Tell me the answer for this quickly, very easy. Some easy question, some good questions, some easy questions, some nice questions we have seen. Okay, a mixture of questions we have seen from the complete SQL. Did you enjoy all these questions so far? All the questions that we have taken, did you enjoy them? Tell me. A lot of different variety questions I have taken. Basically on the internet, whatever I found, I have taken on the internet. See, I was searching like, okay, whatever question of SQL came in front of me, I have taken. It is very hard to find SQL questions, good SQL questions on the internet. Okay, so whatever question I found, I have taken. So anyway, tell me the answer for this question. So you can notice, for performing SQL query, find the number of customers of each country. Find the number of customers of each country. So this type of things you can do using group by, group level aggregation. What is the answer for this one? The question is asking which of the relational algebra expression states that no tuple can be both in these two. What this means? Which of the following relational algebra expression? Which of the following relational algebra expression state that no tuple can be in both R1 and R2? What this means? No tuple can be in both R1 and R2. No tuple can be in both R1 and R2. So means, Nikhil, what this means? Tell me. This means intersection empty, right? This simply means intersection is empty. This simply means intersection is empty. No, this is not exclusive OR. This is intersection empty. It simply means intersection is empty. What is the difference between exclusive OR? Nikhil, why this is not exclusive OR? Why this is not exclusive OR? Because in the exclusive OR, why this is not exclusive OR? No tuple can be in both R1 and R2. It means this is the intersection must be empty, right? They're common. The intersection must be empty. Like what you are saying, I'm not getting your point. What you want to say? That XOR must be what? XOR must be what? XOR must be empty. Are you saying that? Are you saying XOR must be empty? Tell me. Nikhil, are you saying XOR must be empty? Give me your statement. Okay. So anyway, you can check it out. But basically, okay, no tuple can be in both R1 and R2. Okay. So that is basically means that means intersection is empty. So which of the following condition says you that, tells you that? Which of the following condition tells you that? So all the provided answer, no. R1 minus R2 is, this is wrong, right? R1 minus R2 is 5. That simply means R1 is subset. What this means actually? It simply means R2 is subset of R1, right? Agree or not? It simply means R2 is subset of R1. It means R2 is subset of R1. It means R1 is subset of R2. So this is also not correct. R1 union R2 is 5. This is also not correct. You can check it out. What this is saying, cross product, and this is 5. This is also not correct. This is also not correct. So what should be correct? I can say that natural join must be empty. Can I say? Okay, like if one option I give you, so here answer will be what? So this answer is correct, right? So this answer will be correct. But what is alternative? See, can I say that natural join will be empty? Can I say natural join will be empty? Can I say natural join will be empty? Can I say this? Then natural join will be empty. This will be correct because you know AB. Because you know AB. When the schema is same, then natural join is same as intersection. When two things have same schema in the relational algebra, we have seen this. If R, S have same schema, then what will happen? Then R natural join S is same as R intersection S. Okay, so this we already know. Why option C is wrong? C option is correct, right? Are you talking about this? This is not the natural join. This is not the natural join. What this is saying? This is saying that in the cross product, this should not be equal to this, and this should not be equal to this. No tuple should be in. Yeah. Oh, so tell me. Yes. So tell me, why option C is wrong? Why this is wrong? Why this is wrong? Why this is wrong? Why this is wrong? This will be 5. In which situation this will be 5? R1 cross R2. This should, so when it will satisfy, some row will satisfy, then this is not equal to this, and this is not equal to this. So if it is 5, then they are equal. Actually, if this is 5, then they are basically same. This is checking equality of tuples. This option is checking equality of tuples. This is checking equality of tuples. This is okay. This will happen. When this will happen? This will happen if R1 is equal to R2. When R1 is equal to R2, this will happen. Is this clear? When R1 is equal to R2, this will happen. Let me know. Correct or not? So if R1 is equal to R2, this will happen. Right? Yes or no? So this actually tells you about R1 equal to R2. This does not tell you about that their intersection is 5. It tells you about R1 is equal to R2. This option. Okay. In this option, this will be empty. This will be empty. This will be empty if both are same. If both R1 and R2 are same, then this will be empty. Yeah, that's correct. Nikhil, this will be empty. This query will be empty if R1 and R2 are equal. Just check it out. If R1 and R2 are equal, this query will be empty, right? Check it. Nikhil, you can check it. Take some example maybe on your copy pen. Okay. So you can notice this will be empty. This thing will be empty. This thing will be empty if R1 or R2 are equal. So anyway, this is correct. If this is given, then this will be correct. Okay. And what about this question? What are the correct answer? Which of the following are true? The where clause separates the data into different groups. So this is wrong. Where clause does not separate. Group by clause does this. This activity is done by the group by clause. Okay. SQL query must include the from clause. This is mandatory. Select comma from. These are mandatory. SQL query must include where clause. This is not correct. In a query, if you use group by clause, we must also use having clause. No. The as keyword allows column and calculation to appear with a different name. That's correct. Renaming you can do. So the complete revision of SQL we have done in these questions. In these questions, the complete revision I've given. Okay, the complete revision of SQL maybe. Can you see? Okay, so tell me the answer for this. A query is limited to single aggregate calculation in its as select clause. A query is limited to single aggregate calculation. This is false. You can have any, okay, in the select you can have any, like in the select you can have AVG of marks, you can have count star, okay, you can have anything. So this is false. What about the next? What is the answer for the next question? The group by clause, what will be the output? Value for the count star, department comma count star from employees group by department. So the total number of employees you are giving, right? Okay, so basically department, in every department, what is the total number of employees? The total number of employees in each department. So your answer will be option A. Option A will be the answer. What is the answer for this? Specify the correct order in which these clauses must be placed. Must be placed. In which order these must be placed? So first select must be placed. See, this is the syntax order. Syntax order is this. Syntax order. What is that? That is 6. First select must be placed. Okay, select from where. Is this clear? Select from where. After that group by, after that having, and after that order by. This is the syntax order. This is the syntax order. And what is semantic order? What is the conceptual evaluation? Conceptual or semantic order? Evaluation. Execution order. Conceptual execution order. That is what? That is from, then where, then from where, then group by, then having, then select, and then order. Then order by. This is the execution order. Okay, so these are some gate questions. I think, okay, let's take gate questions in the next class. Shall we do that? Okay, I think that is enough for today. For previous question, student, the answer be C. Total number of employees in each department. That's correct, right? Option A is correct. Option A is correct. Yes or no? Employees, department, comma count star. You are doing department comma count star. So this is correct. Okay. What is the doubt? The total number of departments, not that. It will give you the total number of employees in each department. In each department, how many employees you are having? Okay, that is what it will give you. Yes or no? So here answer will be option A. Priya, what is your doubt in this? What is your doubt in this? This is a straightforward question. Okay. The remaining questions we will do tomorrow. Okay, I have taken a lot of questions, but okay, I think see, these a lot of questions I have taken, you can notice. Okay. So but anyway, we will see that. No, tomorrow SQL last topic is there. Tomorrow we will study nested query. That is the last topic. Tomorrow SQL will be completed, and we will also complete the question, like not complete, but almost 15 or 20 questions also we will solve. Okay, from the SQL, and the remaining questions you can solve. Okay, so tomorrow I wanted to have TOC session, but okay, so let's have TOC session also tomorrow. Okay, so tomorrow we will have that. And today you have, in the evening, you have operating system class from 8 p.m. right? Okay, from 8 p.m. you have operating system OS class. So tomorrow morning we will discuss this. So first we will discuss nested queries. Nested queries are really very simple concept. Yuvraj, see, many complicated topics we have seen, and maybe many complicated topics which are complicated for majority of the students, those also we have seen in a very easy manner. Okay, like TRC, like tuple relation calculus. Okay, yeah, decidability. Okay, so many things are there which were complicated, which many students they find complicated, but we have seen them in a very easy manner. Okay, with a lot of questions, a lot of variations. Okay, so like tuple relation calculus was one of them. And so this nested query, let me tell you, this is not even complicated. This nested query, this is not even complicated. Okay, once you study this tomorrow, you will not even put it in the complicated I can say in the complicated part. Okay, so anyway, this nested query is actually very good, very simple. Okay, so tomorrow morning we will start at 8 a.m. Okay, at 8 a.m. we will start. I will definitely try at 8 a.m. Okay, any other doubt? Option C, relation wala, equal wala. What is the doubt in this? This was the question. Yeah, this was the question. What is the doubt? So this will become empty when R1 is equal to R2, right? Yes or no? When this will be empty? When this will be empty? See, this will be empty, means no one will satisfy this condition. This is empty. This is empty. When this is empty. Okay, like this tuple is not there. So this will not be empty. Yeah, only one tuple, right? Yeah, yeah, yes. So this will not be empty if R1 and R2 are same. This will not be empty. So then what is the interpretation of this? This is correct. This will not be empty if you have two tuples, right? Okay, if you have two tuples, like if you have two tuples, in that situation, definitely this will not be empty. Then what is the interpretation of this? When this will be empty, then in which situation this will be empty? In which situation then this will be empty? I think this, then it, okay, single tuple, right? Yeah, okay. So else it cannot be empty, right? Yes or no? Else it cannot be empty. This will not satisfy. This should satisfy. No, even with the two also we can make it empty. Even with the two tuples also we can make it empty. See, Nikhil, even with the two tuples also we can make it empty. We can make it empty even with the two tuples. For example, we can somehow we can create this. Yeah. So this type of situation we can create where this will become empty. Ek tha duplicate tuples are not there. We are talking about the relational algebra. We are talking about the relational algebra. So duplicate tuples we don't have. This is a question related to relational algebra. This is not a question from SQL. So like if you have R1 where you have AB and you have R2 and where you have AB. Okay, so somehow we can like I can give you this, for example, this I will make sure that this condition does not satisfy. Okay, I will make sure that this condition does not satisfy. So what I can do, I can put 1 here, and what I can do, okay, what I can do, I can put uh mm, 1 2 here. Okay, or maybe I can put 2 2 here. Tell me which data should I take so that I can take. So this 1 with this, it will definitely not satisfy. And this I can take 1 2. So this will not satisfy with these two. And I can take 2 2. This 2 2 will not satisfy with the, but now this will satisfy with this. Now this will satisfy with this. So if I make it, Now this will satisfy with this. Now this will satisfy with this. Any tuple we entry, it can map to other duplicate tuple. Okay, so you check it out. I think like I'm not getting a counter example. Okay, you can check it out maybe. For this, so, any tuple we entry, it can map to other duplicate tuple. So what should happen here? See what is happening in this. This is slightly interesting. This is slightly interesting that this is your query that you have R where you have A comma B, and this is your query where you have S comma B, and the condition is this, that this should not be equal to this. This should not be equal to this, and this should not be equal to this. Okay, so I can say this should not be equal to this, and this should not be equal to this. So like it's like this should not happen, and this should not happen. So I can call it this or this should not happen. Okay. So these two must like happen. So when it will be empty, it will be empty if no one satisfies this AB. Okay, and it will be empty if there is no row which will satisfy this. Okay, so if it is not empty, then this type of row must be there. If it is not empty, this should not be equal to this. Okay, and this should not be equal to this, right? So this type of row must be there. So if you want that it should not be empty, then there should be at least one row. There should be at least one row which is distinct. So I can say R1 exclusive or R2. There should be at least one row here, and there should be at least one row here. There should be at least one row which is different from this row. Okay. So Nikhil, can you raise your hand? Hello. Yes, Nikhil.
Hello, sir. Am I audible? Hello.
Yes, Nikhil.
Am I audible, sir?
Yes, yes.
So my counter is this is a relational algebra query, right? So there will be at most one query with a distinct category, right? There cannot be duplicate tuples, right?
Right.
So even if I consider there are greater than equal to two queries in a relational in this relation, so during that cross product, I'll definitely be getting the 4 rows at least.
Right.
And my counter is if we have two distinct rows in the original table, while doing the cross product, we are not going to have, like, we always will be going to have a single tuple that is not going to be that is always going to be satisfying this condition, that A is not equal to A and B is not equal to B.
So basically there must exist a tuple which is here. Now that tuple can be here, I don't care, but there must exist a tuple here, and there must exist a tuple here, such that they are different.
Yes.
So there must exist a tuple here, there must exist a tuple here, there must exist a tuple here, such that they are different. They are completely different. Like T1 and T2, they're completely different in everything. Like in everything. Okay, they are in every attribute.
Yeah, exactly.
In every attribute, they must be different. Like T1 of A must be different from T2 of A. And T1 of so the tables can be same. The tables can be same, or the tables can be different also.
Yes, sir.
Their
I guess.
intersection may be empty, their intersection may not be empty, and it is also possible that they have nothing common.
And they also exist, like if we try to create a case that has more than like more than two tuples, then the like the column of single A, like we need to have tuples like 1 2 1 3 1 4 1 5.
Right.
Then
Mhm.
in that case we are going to have an empty relation at the end.
Right. So
That
I
is,
think the answer for this question will be that what this query is doing. This query is basically when this will be empty, this will be empty. Sorry, this will not be empty if you have this situation. If you
yeah,
have this
exactly.
situation, okay, for every attribute, we can say that this TS should not be equal to TB, sorry, T2A, and this
T1 dot
and this
B is not
T1B
equal
should
to,
not be equal to T2 dot B.
yeah, exactly.
Okay. In this situation, we can say that answer will be in this situation, we can say answer will be not empty.
Not empty.
Your,
Yeah.
let's call it query 4. So then I can say then in this situation, query 4 will be not empty.
Yes,
This
even if there exists a single tuple where this
single tuple is
condition
also fine. Like if this tuple you have in this relation, if this tuple you have in this relation,
cannot
so
be
single
possible.
tuple is also fine.
AB is from different. Okay, it's from different relation, right? Okay.
This you can have in this relation,
Uh-huh.
and this you can have in
2 4
this
can be in
relation.
this relation.
So then
Yes.
also this result will be not empty. Okay, if this happens, then the result will not be empty. If this happens.
Yes, exactly.
Right. So anyway, I think, but anyway, the point is that this is not doing what we wanted to do. We
Yes.
wanted that intersection should be empty, but this query is not telling us that intersection will be empty.
So the general like the point I want to discuss is that there can exist more than one row and still we can have an empty relation at the end.
What can happen? You can have
Like
single
we can
row.
have
Yes.
no, we can have more than one row in a relation and still we can have an empty relation.
Yes. Still you can have empty relation.
Yeah.
Or you can have like one row AB. So tell me, can you give me two rows?
1 2 1 3.
1 2 1 3.
And in the relation 2 I'll have 1 5 1 6.
1 5 1 6.
Yes.
Oh, right. So
even in
yeah,
this case
this also
we
will
are
give
going
you
to have
empty.
an empty.
Right. So for this data also, this query 5, this query 4 will be empty.
Yeah. Even a single tuple, single attribute is getting matched, we can totally like discard that tuple.
Discard that. Right. So this is correct. This condition that we have written, this is correct condition.
Yeah, exactly.
Okay,
Yes,
there
sir.
must exist a row which is completely different from, which is completely like in every attribute. Okay, it should be completely different from there exists a row here. So this would happen. Then this 5 will then this query this let's call this is the query Q4. We are calling this as query Q4. This is your query Q4. Okay.
Yes, sir. Yes, sir.
So yeah. Okay. So I think this type of questions are nice. Maybe some.
They are just like putting like brain exercise kind of questions.
Yes, brain exercise questions. Okay, so
Yes,
now this particular question is not very good because you can solve this question very easily. But maybe some questions, some question can be created. Some very nice question can be created on this option, on this query 4. Some very nice question can be created. Okay.
Yes, sir. Yes, sir.
Any other doubt?
No, sir. All good.
Okay. So in the next class, in the next lecture, we will discuss. This is our next topic. This is tomorrow. Okay, tomorrow what we are going to do. Tomorrow we will finish this SQL. So tomorrow we will study, first of all, we will study nested query. This is our last topic, nested queries. And then all these gate questions we will take. Okay, just like relational algebra, just like TRC, I will take around maybe 15 to 20 gate questions I will try today. Okay, so these many questions we will try today. Okay. Okay, thank you everyone. See you tomorrow. So yeah, so TOC class we will have tomorrow. Okay, and not only decidability, you do the revision of complete TOC. Not only decidability, it's not only about decidability in the GATE exam, only decidability will not come. Okay, let's make sure that in the next 10 or 15 days, let's complete the TOC revision. Okay, so you do the revision. I will make sure that I will cover all the, I can say all the areas I will touch, all the areas, easy, hard, moderate, okay, every topic, pumping lemma, Myhill-Nerod theorem, decidability, countability, finite automata, regular languages, regular grammars, context-free grammars, okay, every topic, closure property, basically every topic I will touch, okay. From every topic, I will take the gate questions, okay. So you keep your revision, okay, the TOC revision you do, and tomorrow we will definitely have this class. Basically today we would have we would have taken this class, but already it is, I can say already it is almost 6, okay. So 5:45, okay. So tomorrow we will continue that, okay. Okay, thank you everyone, see you tomorrow.